I did an issue with some 3D printed parts a while back. They're amazing for what they are, but due to the nature of fused filament printing, they break along the layer lines. It's particularly bad around thinner parts of print. So I had an idea that came from forming other thermoplastics like Kydex. Wouldn't be simple just to print out an object flat and then use a heat gun to form 90-degree angle on it? I did some Googling and I couldn't seem to find anyone else doing this, so I decided to make a video of it. This is just very basic use of it, but it could be used to make other more complicated items that would be stronger, like boxes and other things. And in this case, a in-stop mount for a 3D printer. This is the test object I'm printing. I'll bend it at 90 degrees where the long part is. It's for an in-stop on my 3D printer. The one I was using was a hot glued mess, and the idea here is to print it out flat so the mounting holes go through the layer lines, and then bend it at the long part upwards and glue the limit switch to it. This will make it so it can get hit by the bed and possibly crash and still not break. I've pre-printed one just for this video. I'm gonna hold it up here in a second. There it is. Do the next part. Yeah, there's the completed print. Right about there is where I'm going to heat it up and bend it at. There's the hot mess that was on there before. It would break off whenever the bed hit it, which isn't a very good idea for an in-stop mount. Here I'm showing what would be a normal way to print something. That was a 2.5 plate for a computer bay. As you can see, the prints are running like horizontally through that, as if it were flat like that right there. It's a pair of brass knuckles I printed out to show this right here. There's layer lines going through it. You can see it's very strong. It was designed to hit people with, that have very tiny hands. Same thing there. Strong. But when you press down on the end there, it snaps. And that was the problem I was having with really any print like this, where it's thin, it's not very strong. There's the old Yaesu 858D. So I'm heating at this part right above the right hole. Just adjusting the heat. I'm going to give it a real liberal heating on both sides. And what I'm checking for here is that when it becomes pliable, so I'm pressing against the table to see if it'll bend at all. More heat. A little bit more. It's not an exact science. There it goes, it's bending. Full stiff, and you have to be careful not to underheat it because it'll break the layers apart. Make sure that's pliable enough to actually be bent all the way through. That's why you have to heat both sides of it. Hold it in place for a second, make sure it stiffens up. It cools really quickly. Adjustment. And that's pretty much it. That's how you do it. It's me go through the process of installing it. It's a Ordbot 3D printer. Notice on the left side it has the print that I had actually shown the sped up view of it. It's still on there. That chickbunk's real mad. There it is, installed. Gonna go ahead and install that limit switch. That's all the glue on it. It was just glued onto that stepper motor. It was an awful idea. It didn't work very well. Peel that hot glue off. Or make anything. It needs the necessary amount of hot glue. Just a beautiful wiring job for the heated bed there. Quick mock up where it should go. There it is. There's the glue gun. And just put it on here. Usually the glue gun works pretty well in 3D printed parts. For putting things together that are simple like that. And that's it. Now I can get hit a whole lot and not break at the layers. Thanks for watching. There's no blooper reel at the end of this video. It's just more glue.